In 10.6, we're going to work with some new formulas, the sum and difference formulas. Vocabulary is vocabulary we've had from another section, which is trigonometric identities, which again are rules that are true for all values of all angles. Okay, so their identities are always true, as opposed to equations, which are true for specific values. A type of problem I might want to do in this particular case would be to compare, in this case, the daylight hours for Dallas, Texas to Anchorage, Alaska, which have very different lengths of days, to try to find out on which days of the year the two cities have the same amount of daylight. So we can work with this a little later. That will involve our learning how to solve equations using these formulas. So new formulas that we're going to be looking at are the sum and difference formulas. So the sine of angle A plus angle B would be equal to the sine of A times the cosine of B plus the cosine of A times the sine of B. So we've got all these guys, right? So you'll notice that there's a pattern to them. They're not that different, right? But the big issue here is how do you go ahead and apply them? So let's go ahead and start with working with this. If we have the sine of A plus B, if I go back and I take a look at this, it's going to be the sine of A times the cosine of B plus the cosine of A times the sine of B. So if I do that again, it's going to be the sine of A times the cosine of B plus the cosine of A times the sine of B. Okay, let's make sure I copied that right. I did. Okay, and they've given me values here. They've given me the cosine of A is 4/5 and sine of B is negative 15/17. So that's great and all, but that's not all the data I need, right? If you look at this, I need the sine of A and the cosine of B, so I don't have either of those. I need the cosine of A, which I have, 4/5, and the sine of B, which is negative 15/17. But how do I find the sine of A and the cosine of B? Well, if you remember, we learned that sine squared A plus cosine squared B, I'm sorry, we learned that sine squared theta plus cosine squared theta is equal to 1. So if I do this a couple of times here, I can figure out these values. I'm going to need them for both problems, so I can go ahead and do that. So I know that sine squared theta plus 4/5 squared will equal 1. So sine squared theta plus 16/25 is equal to 1. And then if I subtract 16/25, I'll get that sine squared theta is equal to 9/25. So if I square root either side, sine of theta is equal to 3/5. Okay, great. So I know that sine of A is 3/5. Now if I want to find the cosine of B, I can do the same thing with B. I know that negative 15/17 squared plus cosine squared theta is equal to 1. Right, so if I have 15 squared is 225 and 17 squared is 289, so I'll have 225 over 289 plus cosine squared theta is equal to 1. That means cosine squared theta is equal to 1 minus 225 over 289. So 289 minus 225 would be 64 over 289. So cosine squared theta would be equal to, or sorry, cosine of theta would be equal to 8 over 17. Now, but it's important to think about where these lie. All right, for instance, this is in the first quadrant, so I know that for A, the value is positive. That's fine. Okay, so for A, the values are both going to be positive, which is what we're doing right now. So I know it's going to be 8/17. So let's go back, though, and take a look at angle B. B is between, it's in the fourth quadrant. Okay, so if I find cosine in the fourth quadrant, cosine being related to x, that's also going to be positive, so I'm good with this here. So we'll have 24 over 85 plus negative 60 over 85. The value of that's going to be negative 36 over 85. Okay, I've got the same values, but I'd have a different formula for cosine of A minus B. Let's take a look at that. Cosine of A minus B is cosine times cosine plus sine times sine. All right, so I'll have cosine A cosine B plus sine A times sine B, and cosine A is 4/5, and cosine B, right, when we figured out cosine B, it's 8/17. Plus sine A sine B, so sine of A was 3/5, and sine B is negative 15/17. So over here we'll get 32/85 plus negative 45/85, and this will be equal to negative 13/85. Okay, so we used Pythagorean identities, which we learned in previous section, in order to find missing parts so that we could use this sum and difference formula. Okay, that's how you do it. Go ahead and try that out for yourself. Try problems 13, 14, and 15, and then come back and we'll work on using some more of these formulas. Okay, so now in working with this particular problem, I'm going to have the sine of x minus 3 pi over 2. So if we go back and sine, the difference formula for sine A cosine B minus cosine A sine B. So I know I'm going to have sine of x times the cosine of 3 pi over 2 minus the cosine of x times the sine of 3 pi over 2. Right? If you think of this as A and this is B, I have sine A cosine B is cosine A sine B. Let's make sure I did that right. I did. That's good. Okay, so I know I have sine of x. We're going to solve for x, but cosine of 3 pi over 2. Okay, so 3 pi over 2. Where's that? So here's 0, here's pi. 3 pi over 2 is 270 degrees. So what would be the cosine? The x value for that is 0. So this is times 0. And then we'll have minus cosine of x times the sine of 3 pi over 2. Now the y value here is 1. times 1. So this would simplify, right? That becomes 0. So this becomes the opposite of the cosine of x. Okay, so we don't actually solve for x, but we do simplify it down to something much simpler, okay, by using that formula. So now we're going to use the tangent formula. We used one of those before, and there we go. So we can make sure that we don't get foolish here. All right, so the first thing I have is I have the tangent of a, so that's tangent of x, plus the tangent of b, tangent of pi over 2, all divided by 1 minus the tangent of x times, tangent of x times the tangent of pi over 2. So I'll have tangent of x plus tangent of pi over 2. So pi over 2 is up here. In this case, my tangent is y over x. So y would be 1, x would be 0, so that becomes undefined. And I can't add that in. Over 1 minus tangent of x times, again, undefined. So this is just going to be the tangent of x over 1, which is tangent of x. Alrighty, so again, going back into some simple things from the unit circle and taking what is a more complicated item, meaning we've got two angles being added together, and simplifying it down. Okay, go ahead and try that out yourself. Do problems 25 through 27, and then come on back. Okay, so now we want to work at solving a trigonometric equation. So we're going to be using these cosine formulas. So here are our two cosine formulas. I'm going to want to work with these. So I have the cosine of, this is going to be a plus b, and over here this is a minus b. So a plus b, I'm going to have the cosine of x times cosine of pi over 6 minus the sine of x times the sine of pi over 6 minus the sine of x times the sine of pi over 6 minus 1. So I'm working on this left side. Now I'm going to write out the right side. So we'll have cosine A times cosine B plus sine A sine B. Looks like I let that slide out too far. Right, so I'm going to have the cosine of x times the cosine of pi over 6 plus, I'm going to have to make a new line here, sine of x times the sine of pi over 6. Okay, great. So again, thinking about pi over 6, it's right over here. It's 30 degrees. It's square root of 3 over 2, 1/2 would be the coordinates off the unit circle. So I know that cosine is this and sine is that. So I'm going to have the cosine of x times the square root of 3 over 2 minus the sine of x times 1/2 minus 1 is equal to the cosine of x times the cosine of pi over 6, right? But the cosine of pi over 6, we've already figured that out. Square root of 3 over 2. Plus the sine of x times the sine of pi over 6, which is 1/2. And now we can start to sort of simplify this out. So I have root 3 over 2 times cosine of x. Actually, I don't need the parentheses at this point. Minus 1/2 sine of x minus 1 is equal to root 3 over 2 cosine x plus 1/2 sine x. And if I subtract root 3 over 2 cosine x from either side, those go away. If I subtract 1/2 sine of x, I'll have negative 1/2 sine of x minus 1/2 sine of x. That's just negative sine of x equal to 1. Actually, why don't I add it to either side and leave the 1 alone? So if I have negative 1 is equal to the sine of x. Well, where in my unit circle is my y-coordinate negative 1? Well, that's down here. That's at that's at 3 pi over 2. So x is equal to 3 pi over 2. That doesn't happen anywhere else. Okay, let's do another problem similar to that. Okay, so let me go ahead and set up my problem. I know that this will be equal to the sine of x times the cosine of pi plus the cosine of x times the sine of pi. Right? So we've done this part. And you know what? I'm going to go ahead and subtract this to the other side. So I'm going to put negative. So I'll have cosine of x cosine of pi minus sine of x sine of pi. Okay, so I've worked this all through. Go back to the unit circle. Where's pi? Pi's over here. What are the coordinates there? Well, x is negative 1, y is 0. So cosine is negative 1, so cosine of pi is negative 1. Sine of pi is 0. Okay, now I'm just copying everything else down. Okay, so negative 1 times the sine of x, that's the opposite of the sine of x. This becomes 0. And over here I'm going to have the opposite of cosine of x. And that also becomes 0. So this just becomes cosine of x. So where does the opposite of the sine of x equal cosine of x? Well, going back to the unit circle, this would happen, right? The sine and cosine are equal anywhere we have multiples of 45 degrees. But what we want is a positive x-coordinate where we have a negative y-coordinate. Okay, so, or we could have a negative x-coordinate and a positive y-coordinate, either one. So that would be this quadrant here and this quadrant here, where cosine and sine are opposites. Okay, if you recall over here, my x is radical 2 over 2, and my y is the opposite of radical 2 over 2. And up here, my x is the opposite of radical 2 over 2, and my y is radical 2 over 2. Okay, so these values then would be 3 pi over 4, right? So I have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7 pi over 4. Okay, so you give this a try. Go ahead and do problems 36 and 37. Come on back and we'll do one more where we talk about daylight. Okay, so what we're looking at here is I've got this formula for the hours of daylight in Dallas and this formula for the hours of daylight in Anchorage, and we want to find out the days where they have the same amount. So I could make them equal to each other. 2 sine of pi t over 182 minus 1.35 plus 12.1 is equal to negative 6 times the cosine of pi t over 182 plus 12.1. Okay, that's interesting. So right off the bat, I can see I have 12.1 on either side of the equation. If I subtract 12.1 from either side, I'm going to get that. Okay, that's good. The next thing I can do is I can divide everything by 2, and that will become negative 3. Okay, so on this side, I have negative 3 times the cosine of pi t over 182. And on this side, I have the sine of pi t over 182 minus 1.35. So I didn't write that very well, did I? 1.35. So over here I've got a difference formula. So this is the fellow I want to use at this point. So I know I've got the sine of pi t over 182 times the cosine of 1.35 minus the cosine of pi t over 182 times the sine of 1.35. And that's going to equal negative 3 times the cosine of pi t over 182. Okay. So let's go through and see how we can simplify this. Okay, so the first thing I'm going to want to do is I'm going to want to simplify some of these values. Okay, that's going to be helpful. So I know I can find the cosine. I'm going to leave the sine alone, so it's pi t over 182. But I can find the cosine of 1.35. I have to make sure I'm in radians. So the cosine of 1.35, cosine is 0.219. So let's put that in. 0.219 minus cosine pi t over 182. I'm going to make this a coefficient over here, right? So I want to find the sine of 1.35. That's 0.9757. Right, and then I'm going to add that, right? These and these are now like terms. So I can add 0.9757. So it's almost 1 cosine pi t 182. And I'm going to add it to the other side where there are -3 of them. So over here I'll have sine of pi t over 182 equals, I'm going to go back to my calculator, and I'm going to go ahead and do this and just subtract 3. So I'll get negative 0.2024. Whew, okay, I'm sorry, and this is times 0.219. Can't forget that. Alrighty then, so now, if I divide -2024 by 0.219, let's do that, I'll get negative 9.24. We'll just keep it there. And I'm going to divide both sides by cosine, right? So I divided both sides of the equation by this and by this. So this will be sine of pi t over 182 divided by cosine of pi t over 182 is equal to negative 9.243. Right, well, sine divided by cosine is tangent, so I know tangent of pi t over 182, we're getting there, equals negative 9.243. All right, and now if we go ahead and if the tangent of this will be equal to that, then if I want to find the angle, what this angle is equal to, I do inverse tangent on the other side. So let's go back to the calculator. Here's our value, and we do inverse tangent, and we get negative 1.463. Negative 1.463. And the other thing I would want to remember, if you remember when we were talking here, tangents are equal to each other when they're directly opposite each other on the unit circle. So 1/2 of the unit circle around is pi. Okay, so this will be the correct value there, but then also plus n times pi. Every time I go 1/2 of the way around a circle in either direction, I'll come back to that same value. Right, now if I go ahead and multiply both sides of the equation by 182 and divide them by pi, I'll get t. So I'll have negative 1.463 plus n times pi times 182 over pi. So this is 182 over pi again. When I multiply that times this term, the pi's are going to cancel, and I'll just end up with 182 times n. And then I have to multiply negative 1.463 times 182 and divide it by pi. So let's go back to here. There it is. So I multiply it times 182 equals, and then I divide it by pi equals. So I have negative 84.76. Whew. All right. That was a lot of work. Okay, so what I'm going to do now is I'm going to copy this and I'm going to create a new slide because God, this slide has gotten really, really long. All right, so I'm going to go ahead and insert a blank page. All right, so now we're working with this guy. Well, if I use 0, then I'll get negative days, and that's not what we're looking for. So I could use 1, right? N could equal 1. So we'll have negative 84.76 plus 182 times 1. And N could also equal 2, because even though this will become, right, this would become 364, that's still inside the year. And in that case, I'd have T would be equal to negative 84.76 plus 182 times 2, right, which would be 364. If we go back and we, right, if we add 182 to this, we'll get 97.24. And then to go one more, I'd add another 182. And I get 279.24. All right, so those are the number of days. So I'd have to go back to a calendar and look up the 97th day and the 279th day. Okay, because of course I don't really want to do that. I'm just going to go ahead and look up what the answer is. But if you think about it, right, 30 days about in a month. So January, February, March would take up to 90 days. So this is going to be sometime in April. Right, and if this is going to be a little over 9 months, so it'd be sometime in October. The actual answers are April 8th and October 7th. So April 8th and October 7th. I'm sure I could have looked in a calendar to find that information, but I don't know about you, this was a really long problem and I'm tired of doing it. So there we go. This was a long and rather difficult problem in terms of the number of steps, but we really just kept applying this rule and simplifying and simplifying and simplifying until we got to the end. So that's the end of 10.6. See you in 10.7.